Hello everyone, this is Ari from pantechelearning. So what we are today going to do is today we have already created a ADC. We have created 2 channels and we have gotten the input. So today what we are going to do is we are going to interface add the UART communication with it, and we will display it in the serial monitor. And next is we will also going to in yesterday's before session we have created a ADC DMA. So we have stored the ADC value in the memory using the direct memory access. Today we are going to print we will get the data from the memory and we will print it to the serial monitor. Okay, we will show it to the serial monitor. Okay, then we are going to create a USART using the DMA to receive function. So what it is going to do is it is going to, when we give the value from the serial monitor, it is going to store it in the memory. So you are going to transfer the memory from the peripheral to memory. Okay, it's data from the peripheral to memory. Okay, so we will go to it. Okay, so first we have already created this ADC. Wait, I'll zoom. ADC code. So for reading the channel 1 and 2. Okay. So in which pin it is in the PA of 1 and 2. Okay. So we will now we are going to print this one. So I think we have already discussed this void of send UART. So this is going to get my value, and it is going to check the length of the value I have given, and it is going to add 1 by 1, and it is going to send to this write function. Okay, so I think this I already we have explained. So now what is the step we have to do is we can't directly send the values, because while we are printing we will make the character place the character inside the double quotes or single quotes, right? So here we are not specifying those things. We have to send the value directly. So for that purpose we have to do some function. So we are going to use the print function. Like in C, when you are learning C, you would see in output A plus B. So print of F. If you give a print F of the value means, then you will you can get the value that 2 plus 1 A plus B value you can get it. Like that we are going to use those functions here. So we are going to use this function is here. This first we have to create a okay. So we will create just of 50. So we have created now we have created the array to store character of message. Here my value is going to get stored. So what is the thing I am going to do is I am going to use this print function. So I am going to use this as print. So it is a function which is available in the string.h. So in this we have to give the parameters that now I have to first I will give this msg, then I have to give the what is the thing I am printing. So what is the wait, I will show you. Now I am printing the ADC channel 1, right? So I will give it as ADC channel 1. Okay, so this is the value I am printing. So I have to go. So I have to mention what is the data type I am using. I am using character or a float or a integer. So I am specifying it as an integer. Okay. So now we have specified the format, what is the data type we are using, what is the output data type, and we have said we have sent it to the this message MSG which is we have created. Okay, character message. So what we have to send? So we have to send this ADC of 0 value, right? So next, this value is sent to the stored in this array message of content which has a size of 50. So it is, so this all the ADC channel 1 is stored in this message, and this value also gets stored in this message. Now we have to print this, right? So for this only we have created this send UART function. So now I am going to send this. So send off. Then I will give a space. I will write the function. This will give a new line. Okay. So same step we have to do for this channel 2 also. Okay. I'll copy this and paste this. And this is channel 2, and we have to get the value from position 1. Okay, so now we have developed the code. So we will compile this. So we have no errors. Now I will upload this code. Okay. Okay. Now you have to connect this. So guys, I have to connect this in pin of RS. So guys, this UART setups is already I have explained to you. So the same installation and the same settings. So we are just added to this ADC. That's all. Okay. So we will now go this code. We have connected these pins. Now you have to go to the pin of UART. So now we have to select select the dummy board, which is Arduino of UNO. Uncommon. So now you can see we are getting some values, but it is a garbage value because we didn't specify is equal to 0, so we didn't connect any pins to the channels. Now I will connect it, right? So what is the channel PA of this? So now I connected the pin of PA of 1. So now you can see our channel is now it is resolution is 12-bit resolution, so it is maximum channel value is 4095. So now I will connect this PA of 2 with ground. Okay. So now I am connected to channel 2 with the ground. So now the garbage value is removed. Now the values we can see it is getting 0. So I can interchange this. So now we have changed the channel. So this is how we will bring this value. Okay. So next is next we will go to the Next is we have already created this ADC DMA. So in previous class, so what today we have already stored it in the memory, right? So we have already stored it. We are getting the values from, we are reading the values from the ADC channels, which is 1 and 2 and 16th channel, which is defaultly connected to the temperature sensor, and we are storing it in the memory. So we are using the DMA to peripheral to memory, right? So peripheral to memory. So we have set the direction and we have stored the value in the memory. Now what we are going to do is we are going to print the value from the memory. Okay. So we are going to print the value from the memory to the serial print. We will send those values to the serial print. We will see the temperature sensor value in the serial print. Okay. So what is this? First as previous for in ADC code, we have to create a static character of MSG. Create a message of 50. Okay, size of 50. So now you have created it. Now what is the next step we have to do is we have to use the print function, printf function. So you will do this as print of f. I'm storing those values in MSG. So now I will go as a channel 1 percentage of where I'm going to search for channels 1 value. So it is in the RX data of 0. It is in my memory position of RX data of 0. Okay. So next is I have to send this. Send USART. Then you will give a new line. This will print the 1 by 1 order. Okay. Okay. So we have a printer for channel 1. So std.h. Okay. So now we have to print the channel 1, 2 and 16th value, and I have to print the temperature value also, right? So I will make these things go. Okay. Right, I will zoom it. So I will copy these things because I am going to print 4 values. So this is my channel 2, so it is going to be in the values going to be in the my memory prints of RX data of in first position. So next is channel 16, my temperature sensors channel. So it is in 16. It is in second position. Okay. So next is I have to print this temperature value. Okay. So it is in the float. It will be in the float, right? So I have added it in the float, and it will be not in the float, or etc. It will be in the temperature. Okay. Temperature. Okay, now we will. Sorry, we have no errors. Now we will upload this code and we will get into the serial monitor. Okay. So it is first garbage value readings. So wait. So next you can see now I have connected the channel 1 with the 0 ground, which is ground, and my channel 2 is connected to the 3.3 volt. So it is getting printed, and our temperature sensor is giving a temperature degree of 28 degrees. Somewhat it is not accurate, it is approximately like that. So we can't, so that only we have to use the external temperature sensors. So we can do some pin toggles. Okay. Now my channel 1 is getting 3.3 volt. Okay, right. So this is how we will print these values in the serial monitor. So you can see the outputs in the serial monitor. Okay. So next is so in yesterday's class we have created a DMA transfer, right? So wait a second. So in yesterday's class we have created a code for USART of DMA using USART send for transfer function using DMA. So today we are going to create this. We will alter this code. Okay. So we will alter this code to receive to DMA receive function, to act this code as a receive function, and we will see the we will give some input which will UART gets the input from the user and store it in the memory. So this is what the process we are going to do. Okay, now so before getting into that, so you can now convert this masterclass into an internship, guys. So it is a 1 month on internship and on embedded system. So like this we are creating codes, lots of codes, right? When you are going and practicing those codes, you will get some errors or bugs, lot of these things. So guys, when you join an internship, I will be a mentor for you. I will be guiding you. So you can ask me any doubts, and you can refer those. All the videos will be provided to you. So what is the internship extra features? It is going to add some lots of contents, and it is going to be in crystal clear format, and you will have recorded videos that you can while developing code you can refer to those things. Like that you will have an advantages. So what is the fees? It is 1200, but you don't need to pay the full amount of 1200. You can use this ESMC1 coupon code. So then you will get a 509 of discount price, and you have to pay 691 only. So by paying this, you will get a confirmation letter, internship confirmation letter. So this will very much helpful for you for practicing. And what are the benefits you are going to get? As I said, you will get this 30 days of live session recordings, and it will be accessible for 90 days. It will be accessible. You can see whenever you want. So you can refer whenever you can use this as a reference. And you will get an hands-on practice on embedded projects, and you will get 30 downloadable presentations plus what are the things we are using here. So we are using data sheets, reference manual, lots of things we are using, right? So you will get all these things. All the things will be given to the internship users as a downloadables. You will have a separate downloadable folder. You will get all these things. What are the things we are using for coding and developing this project? So you will get these all the things in downloadables. And what is the main advantages? You will have a one-to-one live session with me in every Saturday class. You can ask me doubts or the doubts related coding, or doubts related the topics I have taught you the past week or the before week, whatever you can ask as per that doubts you have. So you can use those sessions for upskilling yourself. So while you will while developing, you can get some errors. So you can use those opportunities at the class for 11 to 9 session as an opportunity to interact with me. Okay. So then we will get an internship confirmation letter after enrolling. Then you will provide 2 e-certificates, which will be you can mention in your resume for applying for an embedded system, embedded domains. So it will be a participation and as well as close completion. So these are the benefits you are going to get, guys. So don't miss this opportunity. The links will be provided in the chat box. So the registration fee is 1200 only, and the coupon code is ESMC1. Use this to get this discount 509 off. So the final fees you have to pay is 691 only. So use this registration link, guys. So this link will be provided in the WhatsApp group. So you can use those link to register now. So don't miss this opportunity. Already 2 batches is over. So the 3rd batch is getting started. So use this opportunity to, from Monday it is going to be 3rd batch. So you can now go. Don't waste the time. The link is available in the WhatsApp. Link is available in the chat box. You can click that right now and you can join in this internship class as I use it. Okay. So now we will get into the topic. So yesterday we have created the USART DMA, right, for transfer function. So today what we are going to do is we are going to create the function for receiving. So it is going to receive the value from we are going to use that. So we are going to give the value to the controller. So it is going to transfer the values to the memory in using the DMA, direct memory access, with the help of the CPU. This is what DMA is used for. Okay. So first thing we have to do is we will alter this code. Okay. So we are going to use the USART3 only. So you can leave it. So I will make a zoom. Okay. USART3 only. So GPIO, yes, it is as same. Then alternate function, mode, or all the things are same. Then we have given a DMA transmit function. Now we have to change to the DMA receive function. So we have to set it to the receive function. So you have to go to the user. So in this you go to the control register 3. So in control register 3 you will have this bit in the 6th bit. So DMA enable receiver. So we are going to use this DMA as a receive function. So we will enable this receive function. Okay. So DMA of receive 6th bit. So you have to send logic 1 to the 6th bit. Okay. So this is receive. DMA receive. Now the baud rate is same for 16 MHz. Then we have to tune on the. So we have to enable the RE, right, because we are going to receive, right. So we have to enable the RE. So go to the CR1 register. We have an RE in the receiver enabled in the 2nd bit. So we have to change this to 2nd bit. This is okay. Then we have to change this also. So go to the. So you have to send it to the 5th bit. Okay. So this is our XML. So these are the things we have to do for the UART. So we have enabled the UE, everything is set. Then we will come to the DMA of unit. Okay, so we are going to use the DMA as same DMA1. So what is this is, now we have to check the stream. So we have used it. Wait, we will go to the So in DMA1, in our previous session, we have configured for TX, right? So TX is in channel 4 and stream 3. But when it comes with user 3, the RX is in stream 1 and channel 4. So we have to configure the stream 1, right? So what are the things we are going to do? So we are go to the register. So remember, we are going to use the stream 1, okay? Stream 1 in DMA1. So go to the control list. Okay. So already we have given this brief over these. Just wait. So now first we will see the control list. Okay, what is the thing we are going to do is we are going to enable some interrupts. Okay. So for RECE we are going to use the interrupt handler. So we are going to use this. We will start the stream in end of the configuration. So we are going to enable this transfer enable interrupt. So we are going to enable this off transfer interrupt and transfer complete interrupt. Okay. So in CR bit. Okay. First we will set these things. So first is DMA of 1 is equal to stream. In which stream we have USART of RX, it is in the first stream, right? So in stream of 1 in control register we are going to tune on the 3 interrupts. So one is in the second bit, one is in third bit, okay, another one is in fourth bit. We have enabled the interrupt for transfer, off transfer and transfer complete. Okay. So next thing is we have to set the direction. So here we have already set it as memory to peripheral. But what we are going to do is we are going to read the value from the UART and we are going to store it in the memory, right? So we are going to we have to set the direction to peripheral to memory. So in look at now the size here. Right. Direction. We have direction here. So it is peripheral to memory. So we have to send 0 through this. We have to set logic 0 in this 7 and 6. Okay. So we will change this. So it is in the stream 1 of DMA in same register, but okay. So what we are going to do is we will simply left shift of 6. So this is going to set my direction in the logic 0 in these 2, 16 and 6th and 7th bit. So now we have set this value. Okay. So what is the next thing is we have to enable the circular mode because we are going to do the operation continuously, right, for that purpose. So we have enabled it already. Then we have to give the memory increment, not the peripheral increment. So here we are going to peripheral is automatically going to increment as per we are giving the data input. So we have to increment the memory only. So now we have to do the memory increment, not the peripheral increment. Okay, so we should not send 9 because you can see ninth bit is peripheral increment, so we don't need to do that. Okay, so we have to do this memory increment only. So we will do this. Next thing is memory size and P size. So what is the memory size? We have already set as same because still so we have set it as an 8-bit only, because UART is going to send and read my UART is set in the 8-bit of world width. Okay. So next is priority level, it will be the same as low, no problem. So what is the channel is? Channel is same channel. We have to select the 4th channel, but we have to change the streams here, right? So you have to change the streams here. So now we have completed the DMA init function. Next thing what we are going to do is we are going to change these address. Okay, so source address, destination address, size. Okay, we have already declared this. I have said why I declared these all things. So first is NDTR, we will have to say the size there. So we are getting the value from the peripheral right here. So our address is going to be changed here. Okay. And our stream is also going to change. So see, we have to change tier 1, but same register. So 1 and 1. Okay. So what is thing is, now we have to say the peripheral address as a source address, because the memory is going to taken from the peripheral address, because what is the value we are giving, so it is the source. So we have to change this as a source address. Okay. So this is the source address, and destination address is as well as memory, right? As well as memory. Okay. So we are getting the value, we are reading the data from the peripheral, it is the source address, and we are storing it in the memory, which is the destination address. Okay. Okay, we will. So we have created those things. Next is we will take this out. Okay. So now we are going to create an interrupt handler. Okay. So we have enabled the interrupts. So we are going to create an interrupt handler. Before that, I am going to define I am going to define a RX size as 20. Okay. So next is static of so what I am going to do is I am going to create a 3 variables. One is RX buffer. It has a size of 20. Okay. So next is main buff. It has size of 50. We will make it as 50. So next is I am going to create an index is equal to 0. So now we are going to create a interrupt handler. Okay. So for that we have to we will wait, I will show you the interrupt handler where is it is presented. So before that we will add the interrupt handler. Okay. So void of DMA one of string IRQ. So this will be present in the startup file. I will show you guys. Okay. So we have created the buffer and we have created this DMA interrupt handler. Okay, so copy this and paste this. Okay. So what is the first thing we are going to do is inside this loop we are going to create another loop. It is since a loop we are going to create a if condition. Okay. So what is this if is going to check is check my, so go to the register. So we are using this stream 1, right? So we are going with the low register. So we have in low register we have 0 to 3 stream. Okay. So in this we are using a first stream. So you can see we have an interrupts for this. So stream transfer error, off transfer interrupt, which is says when the off transfer is completed, it will give an interrupt. Then transfer complete interrupt. So these are the interrupts we are going to use. So it is in the 10th and 11th bit, right? 10th and 11th bit. So we will check this now. So if DMA of 1 of stream of 1. So in this stream we have to give the, so I am going to check it with this on left shift of 10. So because I have the off transfer complete bit in the 10th position. Okay. So next is, so this is if off transfer complete. Okay. So this is going to say if it is completed means it is going to go into my memory copy of, I am going to copy the main buff. So I am going to give the index and I am going to say the RX buff and I am going to give the size by divided by 2 because the off transfer is only completed, so it is the size of off. So we are going to give it by divided by 2. Okay. Next is we are going to clear these bits. Okay. So for clearing we have the interrupt clear flag registers. So low interrupt clear flag registers, we have to send the logic 1 to the this 10th bit to clear the off transfer interrupt. Okay. So we will go DMA of 1. So I am going to, so this will clear my off transfer interrupt bit. So next is I am going to give an index is equal to index of, so I am going to replace it with the size divided by 2 RX size. So when this interrupt is initiated, when the interrupts is occur, then it will comes to this loop and checks the data and adds the data to the main buffer's value. Okay, this is the process we are creating now. Okay. So next is we are going to check whether the indexes if index is greater than 49, then it is going to reset. I have to reset my index. Okay, equal to 0. So now we have created the function for reading the first of data which is we are giving. Okay, next is we have to create a if. In a stem register. So now we have to check as transfer complete register. Okay, so it is transfer complete register is in the 11th bit. So you can see. Then we have to clear this bit also. So go to the so you have to send this logic onto this in this register also. Okay, to clear this interrupt. Okay, so now we check it with on left shift of 11. So where the transfer complete bit is enabled. Okay, so now if so this is transfer complete. Okay, So next thing is I am going to create the memory copy. So I am going to copy the rest of the values. Main buff, index, then address of RX buff. Okay. So next is, so we are going to, the addresses we have to add from the, because already off transfer is complete, we have to add from the rest of. So we have to give it as size divided by 2. So this is going to add the address from the values from the last. Okay. So let's size of by 2. Okay. So next is DMA of 1. You have to clear this interrupt, right? So I am going to, so this is going to clear me. Okay. So next is we have to do the same thing as this index and size. Okay. Copy this and paste it here. So now we have created the interrupt. Okay. So next is we will come into the get into the main function. So first we will take this block. Okay. So we have to init the UART, we have init the DMA. Now we are using a interrupt, right? So now we are going to get the data from the USART. So we have to change it here. We are going to get the data from the USART data register. So we have to give it USART of 3 of DR. So we are going to get the value from the USART of data register, and I am going to store it in the RX buff. Okay. And what is my size is RX size. Okay. So now we have initiated, we have given the DMA config. Then now we are using a interrupts, right? So we have to enable the navic. So we have to enable the interrupts first. So for that purpose we have a navic of set priority. Okay. Set priority of, so which is a stream, it is DMA of 1 of stream 1. We have in stream 1 we have an IRQN, so which is enables the interrupt. Okay, so we make it as 0. So next is we have to, now we have set the priority for the interrupt. Next we have set the priority as a low. So next is we have to enable the interrupt, right? So for that, so we didn't put, we have closed it. So now see, okay, then we see we have to enable the interrupt. So enable interrupt. So we can set the priority. Priority means which interrupt as per the, if I consider I am doing a lots of things and I am getting a 3 to 4 interrupts. I am getting interrupt from the USART, I am getting an interrupt from the SPI, I am getting interrupt from the ADC. So I have to read any one of the interrupt first, right? So it is at the same time. So I have to set the priority, which thing I have to read. So what is my process? ADC is going to read the value, temperature value and sensor value, and then the SPI is going to, then the UART is going to read the ADC value and going to send it to my serial monitor, and SPI is going to do some operation tuning on the fan, like that operation it is doing, we can consider it. So now the priority will be, the first priority will be ADC, because I have to first know what is the value, what is the temperature is. Then as per the temperature I have to send the value to the USART, and I have to say if the temperature is more than 50 degrees Celsius means I have to tune off the engine. Like that I have to send the command. So first priority is ADC, next second priority is engine, tuning of the engine, the third priority is displaying the value. So this is for this purpose only we will set the priorities. Okay. So next is DMA enable, stream of DMA, we have to enable the stream. Okay. So we will have the stream, DMA stream of 1 of IRQN. So this will enable my inter for the DMA stream 1. So now we have finished the setups. Okay. So now we will, what is the USART we have been using? Pins are USART 3 means it will be the same pins. Wait a second guys, I will make the connections and I will. So we have to connect the RX, right? So RX will be so what are these pins we have configured is 11 and this PB11 and 10. So PB10 is TX. So I have to do this. So now we have come to these pins. Okay. So now we will upload this code. So before that we have to select the what is the debugger we are using. So we will, I am using this ST-Link debugger. So okay. So wait, I have not even connected. Okay. So now I have connected. Okay. So now we will upload this code. So now we will see the debug out. Okay. So go to the debug output and so we will create a watch for this RF buff. Watch 1. We will see the main buff also. So now what we will do is we will open the serial monitor. Okay. So the serial monitor is already connected. Okay. So now we will enable this, start this program to run, and we will send some data to it. Okay. So wait a second. So we will. So this is the same code, so we will see this. Okay, so go to the main. We will run this first, then go to the ID. So you can see I am giving the value which is getting stored in the memory, right? So this is the, we will send the values. So I can send like this things, or like it's just like it will go like 42, like this things. So now we have seen the DMA of receive function. So then in previous coding we have saw the we have seen the UART of transfer, because we have taken the value from the ADC memory value. So ADC is saving the value in the memory, so we have read the value from the ADC. Okay. So guys, today's class is over. We will meet on tomorrow's session with the next topic. Okay. So okay guys. So thank you.